what I'd like to do is determine if this is a function relationship. So what we have so far is we have an equation, and we want to determine, is this a function relationship as x? And so far when we're looking at functions, we've pretty much been looking at ordered pairs, and we've also been looking at kind of circles. But now we're going to look at an equation and determine if y is a function of x. So when we're determining that, we're still going to use the same criteria. We need to make sure that everything in x is mapped to a y, and then also that my x values, they have to be uniquely go to a y. So therefore we can't have multiple values. The first thing I want to do when I'm trying to determine if x is a function of y, is y is a function of x, what I need to do is I need to first solve for y. So I'm going to isolate the y variable by subtracting an x. Therefore I have y squared equals 4 minus x. Now, the next thing I need to do is I'm going to take the square root. That is going to get rid of my y, or y squared. Therefore I'm left with y equals plus or minus the square root of 4 minus x. And remember, the reason why we get our square, or the plus or minus, if I was going to take the square root of 4, you guys can think of this as your input value, there's actually two answers for this, right? The square root of 4 could be negative 2 squared, or it could also be 2 squared. So therefore, we don't have a unique map anymore. My input now has actually two possible values. So therefore, when you're looking for y, is it a function of x as x? Well, in this case, it's not going to be, because we have a plus and a minus for our x values yield a plus and or minus solution for y. So therefore, since we have multiple possible answers for our y values, this is not going to be a function of y in terms of x.